Is that a byproduct?
Now, the process of converting that CO2, even though we can have this little bit take place in the plasma of the blood, the process of converting it into something that's not going to affect the pH of the blood occurs quickest in a red blood cell. Okay? I'm sorry, I'm getting to your answer. What was the question again?
What does it mean to exchange byproduct
Now,
ions for chlorine?
this chloride shift. Now remember, when we're converting the CO2, we produce a bicarb, but we also produce the H+. And the H+ we need to take care of. We're going to need this shift for the chlorine to do that. Because what will happen, okay? What will happen is when this occurs, this exchange of the bicarb for chlorine, okay? This exchange that'll take place. What it'll allow to happen is that bicarb, this HCO3-, which is buffered, it'll allow it to move out of that red blood cell and be existing in the blood fluid, okay? But I still have an H+ that I've got to deal with. And so this H+, basically, it'll help combine this H+ to a hemoglobin, and therefore buffer the H+.
How does the H+ not combine with the chloride?
Because what it's doing is it's wanting to, as we exchange the chlorine for the bicarb, we want to make sure that the H+, we can bind it to either this oxyhemoglobin or deoxyhemoglobin. So we're not doing the H+ to a chlorine that you think of like for maybe hydrochloric acid, okay? No, what we're trying to do is make that H+ bind to a hemoglobin, because believe it or not, that's going to affect the oxygen movement. So it's not turning it into an acid, it's buffering the H+.
And you said what? Wait, so what buffers the H+ again?
The chlorine.
Okay, that's fine.
The chlorine. Because the chlorine will actually affect that H+. Like if I've got my hemoglobin, okay, and if I can exchange the bicarb for chlorine, my chlorine will come in. The chlorine will, I guess, increase the affinity of the hemoglobin for the H+, and the H+ will attach to that hemoglobin. When it attaches to that hemoglobin, hemoglobin has the oxygen, it's going to affect the oxygen.
Does the oxygen drop off?
Well, what we're looking for is to take the oxygen and release it into the tissues. So if we can get the H+ to that hemoglobin, the hemoglobin is going to let go of the oxygen. The oxygen now gets to move into the tissue fluid. It's kind of a control mechanism because not every tissue needs oxygen, a bunch of oxygen dropped off. So if we can get the H+ to the hemoglobin, the H+ is going to allow an oxygen to be dropped off. Doesn't mean that we've got to drop off every single one of them, okay? We might only need to drop off one or two, and we still have two that might be remaining, or one that might be remaining. Now the importance of this process, okay, I shouldn't say I love it, but I watch a bunch of these like shows, like the Discovery Life, where it's like trauma and the ER and everything. And when something has happened and the person's blood supply or the oxygen has been lost or whatever, they always say, I've got 5 minutes I've got 5 minutes, right? Like if you have something that cuts off the blood supply or whatever, you've got 5 minutes. Because this process controls the drop off of oxygen at the tissues, for the most part, unless it's like something really hefty going on in your body, those red blood cells, those hemoglobins, they're going to keep some oxygens. Okay? So they're not going to drop off every single oxygen they have. And do you guys remember how in the venous system there's a huge reserve of blood because it takes longer for it to return, because we got to move against gravity and we got to deal with the muscle contractions and that sort of thing. So this becomes important in situations because that blood contains the oxygen reserve. So this is why in emergency situations they talk about, I have 5 minutes, I have 5 minutes. And if they start doing something to restore the oxygen flow to the brain, because what are they concerned about? They're concerned about the brain, okay? So if that oxygen has been cut off to the brain, that's what they're concerned with, okay? And that venous blood has roughly enough oxygen at a very low level, okay, to supply the brain for roughly that 4 to 5 minute time frame. And then if you go past that 4 to 5 minute time frame, what can happen to that person? Brain damage. So this process of loading, unloading, trying to buffer these H pluses, letting go of the oxygens, picking up the CO2s, it's a pretty important process occurring at these two levels, occurring at the level of either the alveoli or the level of the system at the tissues. So if we think about the gas exchange, have y'all looked at this figure in your book yet? Do you understand it? Okay, you're going to understand it now. Okay? Note, we're looking at it at the level of the tissues right here. So at the level of the tissues, we want to make sure CO2 loads, O2 unloads. The CO2 can be carried in one of the three forms. All right? A little bit of it as the dissolved gas, a little bit of it as that plasma protein. The majority, we're going to see it move into this red blood cell in the presence of the carbonic anhydrase, be turned into this carbonic acid. The carbonic acid will be broken down into the bicarb and the H+. Now watch what happens, okay? The red blood cell wants to exchange the bicarb ion for chlorine. So the chlorine moves in, the bicarb moves out. In the presence of the chlorine, we can take an H+, get it to bind on a hemoglobin in here, and buffer so that we're not affecting the pH of the blood. The other thing that the H+ can do, the H+ can move to, see how they're representing an oxyhemoglobin? Because it contains an oxygen. Is everybody following me? The H+, if it comes and binds with this oxyhemoglobin, it's going to make it release its oxygen, and the oxygen gets to move into the tissues. And in this process that we're doing, we're keeping the pH of the blood buffered at roughly that 7.45 of what it should be. And that bicarb ion that's in the blood The bicarb ion, when we get to the lung tissue, will diffuse across the respiratory membrane as the CO2, because it'll break apart, go into the lungs, CO2, breathe it out. Now, do you understand the picture?
So how does this affect the heme group?
It doesn't.
It does.
It doesn't. Mm-mm. Now, what will happen is that heme group will be affected when we get back to the alveolar. The alveoli. Because if we get back to an alveolus, okay, and if we've got that hemoglobin, and those heme groups are empty, if the oxygen moves across into that red blood cell, what will happen is if one of them can attach to one of those heme groups, it'll change shape, and it'll make the other three want to pick up oxygens also. So depending on how long it's in contact with the lung tissue, it might pick up 1 more, 2 more, or 3 more. Take a break. We're back at 12:30.
Michael Jackson slept in the hyperbaric chamber.